Welcome to Study Loop.
This is the answer to Chapter 13, problem number 13 from the Smith Organic Chemistry textbook. And in this problem, we are asked which of the following has higher energy. And then for A, we're asked between IR light of 3000 wave number and IR light of 1500 wave number. And for B, we're asked about IR light having a wavelength of 10 micrometers or 20 micrometers. And so we should remember to solve this problem that frequency is a way of representing energy. And so the light with a higher frequency is going to have a higher energy. And then across the top here, I've written two proportionality rules that we can use to solve this problem. So wave number, which is expressed as centimeters to the -1, is directly proportional to frequency and therefore energy. So a higher wave number is going to mean a higher frequency and a higher energy, whereas wavelength, which is expressed as lambda, is inversely proportional to frequency and therefore energy. And so a higher wavelength is going to be a lower frequency and a lower energy. So with these two rules in mind, A is asking us to compare wave numbers. So the higher wave number is going to have the higher frequency and therefore the higher energy. So 3000 is twice as much as 1500. So 3000 is going to have the higher frequency and of course also higher energy. Okay, and then so the case is just the opposite in B, where we're asked to compare light on the basis of wavelengths. So a larger wavelength is going to correspond to a smaller frequency and a smaller energy. So a smaller wavelength will have more energy. And so 10 micrometers is less than 20 micrometers. So 10 micrometers is going to have the higher wavelength, or pardon me, the higher frequency and the higher energy. Okay, and so that's the way to solve this problem. We just need to remember the two rules that I wrote across the top. Wave number is directly proportional to frequency. Wavelength is inversely proportional to frequency. And we need to just also remember that frequency is a way to represent energy here. And with those three things in mind, it becomes very straightforward to say which of each of these pairs is going to be higher energy. And that's the answer to Chapter 13, problem number 13.